Hi dears, we will be seeing this sum. The foreman of ABC mining company has estimated the average quantity of iron ore extracted to be 36.8 tons per shift and the sample standard deviation to be 2.8 tons per shift. Based upon a random selection of 4 shifts and set a 90% confidence interval around this estimate. So with this sum we'll solve it. What and all is given, we'll try to write it down. The first one, solution. Okay, what is given? As the standard deviation of the population is not known. In this question, we don't have the standard deviation, right? So, whatever is given, we'll solve it accordingly. So, what is given here is the standard deviation is not known and the size of the sample is small. What is the size of the sample? Here it is given that 38% and 4 shifts. Only the size of the sample is small, right? Because of this condition, we have to okay, whatever is given we'll take. Solution. Okay, the size of the sample is too small because it is only 4 shifts. So the size is 4, n is 4. 4 shifts it is given, so therefore n is 4. The size of the sample is small, as I told you before. We cannot use the normal distribution, therefore we have to use the T distribution. Okay, as a standard deviation of the population, here sigma is not known. Okay, sigma is not known, the size of the sample is small, therefore we use the T distribution. The required confidence interval about the population mean. Okay, so the given the given information we'll write, whatever information given here is n equal to 4, x bar equal to the tons. What is the tons given here is 36.8 tons per shift. This is what given here, right? The average quantity of iron ore extracted to be 36.8. That is the reason x bar is 36.8, right? Now sigma is, this is the standard deviation of the sample. Okay, the standard deviation, the sample standard deviation here you can see the sample standard deviation is 2.8 tons. So it will be 2.8 tons per shift. So x bar, what is x bar given here? X bar is 36. Okay, what is given? Average. Okay, average quantity. It is 36.8. That's why we took x bar as 36.8 and we took the sample standard deviation. Okay, 2.8 tons. So we took 2.8 tons, right? So these are the information given to us, and then degree of freedom. So we'll discuss about the degree of freedom. What is the degree of freedom? Okay. Degree of freedom. Degree of freedom is nothing but n minus 1 here. N is what? 4. 4 minus 1, that is equal to 3. And what about T? T given to construct a 90% confidence interval. Okay, so we have to find the critical value of t is value of t for 90% confidence interval. Okay, or 90% confidence interval is same as 100 minus 90, that is 10% level of significance. So what is given here is confidence interval is 90, that is same as 100 minus 90, that is 10% level of significance. 10% is what? 10% is nothing but 10 upon 100, that is 0.10. Okay, we have to see 0.10 percent level of this level of significance. Now we will see the T table for 3 degree of freedom, right? Remember. So we have to see the T table. See here, this is 3 degree of freedom and 0.10, they coincide here, 2.35. Okay. So is 2.35, okay, for 3 degree of freedom. This we have saw as per table of T distribution. Okay, as per table of T distribution. This is from the table of T distribution, right? So what is the formula? X bar plus or minus T sigma s by root 10. Okay, so X bar will be 36.8 plus or minus T value is 2.35 into sigma s is 2.8 by n is what? 4. So we are trying to estimate. So this will be 36.8 plus or minus 2.35 into 1.4. So this value will be, it's divide 2 now, 2 it will be 1.4, right? So this value if we calculate, it will be like 36.8 plus or minus 3.294, okay, tons per shift. So we are having the confidence interval. Actually we are calculating the interval, right? Point estimate and interval estimate. We have seen now this is interval estimate. That is 36.8 plus this is 8. Okay, 36.8 plus 3.294. You may be getting little bit value here or there. It does not matter. 8 plus 2. Okay, 8 plus 2, 10 carry 1, 6, 7, 8, 9, 10 carry 1, 40. So the confidence interval will be 40.09. Okay, comma. Okay, now you should subtract 36.8, 3.294. Okay, if you subtract what you will get? 6. Okay, 9 minus 9, 0. 7 minus 2, 5. Okay, 6 minus 3 is 3, 33. Okay, it will be 33.506. 506. This is the interval. So they finally what what is the question asked? We'll go back to the question. Back to the question. One second, it takes a little bit time. So what is asked, we should see, right? Construct 90% confidence interval around this estimate. So we are estimating. Estimating what? Average quantity of iron ore. Okay. So what is given? The foreman of ABC Mining Company has estimated the average quantity of iron ore extracted to be 36.8 tons per shift. The sample standard deviation to be 2.8 tons per shift based upon the random selection of 4 shifts. They have taken the sample size as 4. Construct 90% confidence interval around this estimate. Therefore, the sample we have calculated from the sample, right? Therefore, for population mean will lie in this interval. Okay, what is that interval? We have just now written. Population mean will lie in that interval, right? Will lie in the interval that is 40.9, 33.10, right? So this is what we have seen. Now we will go to the next sum. What is the next sum? Okay, estimating the population proportion. Next topic we will see. Previously we saw estimating the population mean. That was our previous topic. Now we go to the next topic. Sorry, bit slow. Okay, we'll discuss it. What is the next topic is nothing but estimating population proportion. Okay, that is our next topic. So what is this? As far as the point estimate is concerned, point estimate we are going to see. As far as point estimate is concerned, okay, estimating population proportion. Okay, we have thought, means we have a proportion it is, okay. We have learnt about the estimating population mean, okay, the sample proportion P, and we have learnt about the point estimate, means exact number it will be. So sample proportion P of units that have a particular characteristics is the best estimator of the population proportion P, okay, and its sampling distribution. So long as the sample is sufficiently large, approximates the normal distribution. If the sample is large, then it will be, can use the normal distribution, right? If the sample is small, means the size of the sample is less than 30, then we call it as a small sample. If the size of the sample is greater than 30, it is said to be the large sample. So the sample proportion P, okay, of units that have a particular characteristics, okay, the population proportion P of units that have a particular characteristics is the best estimator of the population proportion is noted by P cap. Population proportion is noted by P cap, and its